Hi everyone. In the previous video, we looked at creating a Postgres deployment inside our cluster, but we didn't really go into creating anything inside that deployment. So we still have our default Postgres database with a public schema, right? Super default database. In this video, we're going to create a database migration for a project we're going to deploy in the future, a .NET API. And we're going to run that migration inside the cluster to create our database schema. So let's get started. All right, we don't need to be looking at pgadmin for now. You can see here in the cluster, we're running the Postgres deployment. So there are 4 steps that we need to take in order to get our migration into the database. First, of course, we need to create that migration. And that's going to be using SQL files. The second step will be to create a container out of those SQL files. Third will be to get that container into the cluster container registry. And then last will be, of course, to run the container as a job inside the cluster. So let's get started with step number 1, creating the migration. All right, so I'm in Writer, and you can see that this is the solution that has the API project as well as the data project. And the data project is where our migrations are. Now, when we're migrating to production, okay, this like obviously Minikube is not production, but I'm going to show you how to do it for production. We're not going to be using just .NET EF migrate or .NET EF migrations update. Like, we're not going to be using that command. What we're going to do is we're going to actually generate SQL scripts, and we're going to run those scripts against the database. So what do we need to do to get those scripts? Well, I'm here in the folder. If we take a look at what's in here, you can see that we have a SQL folder. Now there's nothing in there. There's a Docker file in there, but there are no SQL scripts in there. So what we're gonna do is we're gonna actually generate those SQL scripts right here with .NET EF. So let's type that in, .NET EF migrations, and we're gonna say script, because we're generating a script. Now we need to tell it what the startup project is. So we'll say startup project, and then where is that project at? So all of my stuff is inside the src folder. So we'll put that in there. We'll say homey.api because that's, I mean, you can see it in the Solution Explorer up there. And then homey.api csproj. Now we also need to tell it where to put the SQL scripts. So that's going to be the -o parameter, and in there we're going to say just .SQL. We can also name the SQL script, and we actually want to do that because that name is what we're going to use later when we're building the Docker image. So we'll just call it a db migration.sql. Now theoretically this should run. Let's press enter and see. And it's going to do a build, and it throws an exception. But this exception, which is kind of hard to read on dark mode, says the host was aborted. Well, that's okay, because really what that means is that we have a try catch and a finally around our builder here, and then run async. So when this exits, it catches an exception, which you can see here: application terminated unexpectedly. Application terminated unexpectedly, right? Same one, but actually is okay. So in order to see if we actually got our scripts, let's go into our SQL folder and see what we got in here. Okay, we have our db migrations.sql file, and we also have a Docker file, which we're going to look at next, because that's what we're going to be doing. We're going to be building a container. All right, so now that we have our SQL script, we can actually take a look at our Docker file. And I've added it to this shared logical folder, not an actual folder. The file is still inside the SQL folder on the disk. But inside our solution, it's inside shared, and it's a Docker file. Now this Docker file is kind of misleading, right? I should name it something else, but it's very simple. Now, what is a Docker file? I'm sure you already know. I don't need to explain. We are going to be pulling from the Postgres 16 image from Docker Hub. We're going to be working inside the /SQL folder, and we're going to copy every SQL file into that folder. And since the only SQL file is this one, well, it's really all we need. Now, there could be potentially multiple databases, multiple migrations for these databases. So I like to just have this just in case. If there's only one file, that's fine, no big deal. And last, we have an entry point. Now, this is not necessarily required, but what we are doing here is we're running a shell script. And inside that shell script, now do remember this is Postgres 16 image, so we do have access to shell. First of all, we're exporting an environment variable, but then we are saying for every SQL file, which again, there's only one, run this psql command and apply, first of all, connect to this host with this user and this database, and then run this file, which is this file right here, this F, right? So where are these being gotten from? We'll get there when we get to looking at the Helm chart. But this is the entry point for that Docker image. Now, this entry point actually not required because we are going to be defining the same thing inside the Helm chart. But if you wanted to run this image not inside the cluster, just by yourself against some database somewhere, you could, because you have this entry point here. Now, of course, you would need to define these environment variables yourself, but so it is. All right, now that we have the Docker file, the next step is going to be to create the Docker image and then store that image inside the cluster repository. So let's switch over back to terminal and see what we got. All right, to get this up and running, there's a bit of a hack that we need to do. Minikube has a registry which it hosts within the cluster. And when we're building our image, what we want to do is we want to say, hey, build this image inside the cluster. That way, we don't need to worry about uploading it to like Docker Hub or Azure Container Registry or anything like that. It's going to be built, and it's going to be built right inside the cluster, so we can run it immediately. But before we can do that, there's a command that we need to run. And I have the command here on the Minikube website, which I just copied, and I'm going to paste it right in here. And this is basically saying that every command that we do for Docker is going to be happening inside Minikube. So that's really what's happening there. So if we press enter, type that in, you don't see anything, any printout or anything else. But now, when we're building the Docker image, it's going to build inside the cluster. So first of all, what we can do is, well, we're going to use the Docker command, right? So we're going to say Docker images, and we're going to see that, whoops, when I say images, I mean image. We're going to see that, wow, what are these images, right? Well, these images are images that Minikube needs in order to run. So let's clear this up. Let's build our own image. And to do that, we run a very simple command. Actually, I don't even need to copy and paste it. Basically, it's just a regular Docker build command. So we're going to tag it. We're going to call it localhost 5000. That's kind of the, first you put the domain and the port, and the internal port of the registry, I think is 5000. And then we're going to say db migration, and then we're going to say latest at the end. And of course, we need to specify what we're building. So since we are already inside the SQL folder, we can just say dot, and it's going to build that image for us. There you go. Now that it's built, again, you can say Docker image list, and you can see that we have the localhost 5000 db migration image with the tag latest. All right, great. So now that we have the image inside the registry, we can actually go straight to the Helm chart. So let's take a look at that. Here is the Helm chart. It's very, very straightforward. So we have our chart.yaml. You can see it's called migration.-job, and just a couple other things that are irrelevant. We have our values file. There are a few things in there that we need. And then we only have one thing called job.yaml. Now, this is a type or a kind of job. What a job is in Kubernetes is essentially a console app that runs just once and then turns off. So for example, you need some data processing or something like that. You can do that with a job. There's also a cron job, which essentially does the same thing, just on a timer. And the Kubernetes cluster keeps track of when that job's supposed to run. In our case, all we really need is the job. And it does two things. It creates the database first, if it doesn't exist, because if the database is not there, how do we run a SQL migration, right? So we need a database. And then once we have it, we will run our Docker image. So metadata, nothing to see here. This is an interesting property. Time to live, seconds after finished. So once the job finishes, it will remain for 60 seconds so you can see the logs for it. So if it failed or if it succeeded, you can go in there, you can take a look at the logs. So I have it set to 60 seconds, and you'll see what that looks like in K8s after we're done running it. Then we're looking at the spec for the job. We're telling it the image that we want. So if you recall back in the Postgres land, when we looked at the deployment, we also told it the image. In our case, we're saying, hey, we want to pull from the localhost registry. We want to pull the image called db-migrations, which you can see here, db migration, with the tag latest. Now you can, of course, you can make this parameterized, you can extract this out into be like a registry value and all this other stuff. Totally can do. And in fact, I do that at work in production. We do parameterize this whole thing. But in our case, pretty simple. Let's keep it as is. Image pool policy, if not present. So if the image is already there, we don't need it anymore, right? And then this is the key part here. These are the environment variables. So if you recall, inside our Docker file, we were pulling some environment variables. Well, these are these. And they are reading from the secret name. The secret name is a secret that we created in our previous video about Postgres. Link up above if you want to take a look at that, which is a secret. It's a basic auth secret. So we're pulling these right here once again from within the cluster. The DB name is pulled from values.yaml. And then Postgres service is the service where Postgres is running, which you can see defined right here. And then we're getting into the command part of this. So there's a couple things. First, we're just running a shell script. Second, we have the Postgres password that we need to set. Then we're waiting until the Postgres database is ready. And once it's ready, we run these two psql commands. So what is this psql command? Well, first, go ahead and connect to this host using this username. And the password is going to be read from this pg password over here. And execute a SQL command. So first, find me a database with this database name. If it doesn't exist, and again, the DB name is pulled from an environment variable right here, DB name. So find me this database, right? And if it doesn't exist, go ahead and create it. Create database DB name, right? That's what that does. So it creates the database. And then the second command, really all it does is it runs a SQL script, essentially -f. So again, psql, then connect to the host using the user. For the database, run this file, /sql db-migration.sql. And then you can recall this /sql is the work directory that we defined in our Docker file. So it's a bit confusing, but stay with me here. That's it. That's what this script does. So now that we have this script all set up, next thing we can do is we can run this Helm chart and see what we got. Back in the terminal, let's take a look at what we have installed so far. So we can say helm-list, and we can see what we got. So far, we've got just the cluster and Postgres in the previous videos that we've created. Next, we need to just create the migration. Now, in order to do that, we need to actually go into our Helm folder. So this is going to be inside here and inside here. You can see these are the Helm charts. So let's go inside migration job, see what we got. Here's our Helm chart. Now, just as before we did last time, what we're going to do is we're going to do Helm install, and we're going to give it a name. So we have cluster and Postgres. Let's just call it DB migration to be consistent. And we can just say dot because we are already inside the folder. So if we press enter, we see here that deployment occurred. And if we go over here, we can see that, wow, well, it was really fast. 7 seconds ago, 9 seconds ago, this migration ran. Now, if we go in here, we see that there was one single pod. And if we go in here, we can see that a ton of stuff happened. Tables were created, indexes were created, like records were inserted, and everything was committed inside this transaction. So we see that the migration ran. You can see 30 seconds has passed. So I'm going to fast forward a little bit with the magic of editing, and you're going to see that the job's going to disappear after 60 seconds. All right, and we're coming up on the 60 seconds here, and 60, and bam, it's gone. So the TTL, time to live, keeps it like relevant for 60 seconds and then deletes it so it doesn't pollute our K9s window. Next, let's take a look at pgadmin just to make sure that everything was created as expected. All right, so we're in pgadmin, and let's take a refresh over here. Oh, well, look at that. We have a new database, homie_db. So let's pop that open. Let's look at our schemas. And we have a public schema with tables. Woo, look at that. We have our tables. We run our migration. We have all the tables that we need. Everything is just as it should be. Well, columns and everything. So in the next video, we're going to deploy our API, which is going to then connect to this database. Pretty simple. You're going to be able to see another deployment here. We're going to take a look at the Helm chart, what goes into a deployment of a .NET service, and then what kind of Docker file you need and stuff like that. So if that sounds interesting to you, stay tuned for the next video. I'll see you there. Take care.